Hello everyone and welcome back. In this video we will look at comparing and transforming distributions. So how do we compare different distributions? Well, certain graphical displays can be quite useful when we want to compare different groups. If we're dealing with 2 or 3 distributions, then we can use either histograms or Stem-and-Lee plots for the comparisons. But if we're dealing with many more distributions, then side-by-side box plots are more ideal. Now, when we're comparing distributions, be sure to look out for their shapes, their centers, their spreads, and note any outliers. So let's take a look at an example. Here are the box plots for the points scored during the first 10 games of the basketball season for Carolyn and Alexandra. Now, the coach can only take one of these players to the state championship. So which player should the coach take, knowing that she would like a safe player? So let's suppose we're given these options. Should the coach take Alexandra because she is the more consistent player? Should the coach take either of them because both girls have a median score of about 18 points? Should the coach take Carolyn because she is the more consistent player? Or should the coach take Alexandra because her interquartile range is the largest? Let's first describe their distributions and look for similarities and differences. We see that the medians, which are the line inside of the box plots, are both at 18 points. So they both have the same center, which is the median. So we see that the medians are both in the center of the box, and the left and the right whiskers for each of their box plots are relatively the same length. And so this tells us that both of these distributions are symmetric. So what's different between their box plots is their spread or their variation. We see from Alexandra that she has the larger spread or the larger variation. So if we want to pick a player that is safe or is more consistent, then we want to choose the player that has the lower amount of spread. So if we look at Carolyn's box plots, we see that she can score consistently between 15 and to about 21 points, whereas for Alexandra, her points can score anywhere between 8 to about 27 points. So Alexandra has the larger spread or variation. And so if the coach wants to choose the safest player, then she should choose Carolyn because she is the more consistent player, as she has the least amount of variation with her points. So now we will look at transforming data. In many of our statistical tests that we will study, the test will not work well if we have extremely skewed distributions. So it may be helpful to apply a transformation first so that the distribution is more symmetrical. So the example here shows the CEO's compensation where the distribution is extremely skewed to the right. So the mean of the distribution is about 10.47 million and the median is about 6.96 million. So we can apply a log base 10 transformation of the data to obtain the following histogram. So on the log scale, we see that this distribution is much more symmetrical than the original. So we can look at calculating the mean and median of the log compensations, which are about 6.84. Now, because this is on the log scale, we need to convert this value back to the original scale by applying an inverse transformation. So the inverse transformation of the log base 10 is to raise the value to a base of 10. And so 10 to the power of 6.84 gives us about 6.9 million. And so this would be describing the center of the original distribution. So this will conclude our lesson for this video. In the next video, we will talk about standardizing data and modeling distributions using what is called a normal model. And I'll see you all then.